Good afternoon and welcome to Lecture 5, the different PID controller variations. So today we will learn what are the different PID controller variations, when to use each one, and then finally the pros and the cons of each. So when you make a system and you need to control it, one of the questions you may ask yourself, do I really need to use all PI and D parameters? Do I need proportional, integral, and differential control? So no, not really. Depending on your system, it may not be necessary to use all three PID parameters. So if you reduce the amount of parameters you use, you actually make it easier to tune the controller. And then it's also computationally cheaper to use less parameters. Okay, the first type of controller, the P controller, the simplest, just proportional control. Okay, this only uses proportional control, KP. Use this if you need fast response, but only use this if your system is relatively stable to begin with. If there are any system instabilities, avoid using P control or proportional control. So the applications of this are very basic motor control. To be honest, I don't think there are many applications of the simple P controller because it doesn't make much improvements to your system to begin with. Okay, the pros and the cons of proportional control. So the pros are it's very simple to implement because you're just doing a simple multiplication of the error, very minimal tuning and quite easy to tune too. And it's also computationally cheap because you're just multiplying. That's it. Okay, the cons. There will be steady state errors such as an offset, overshoot. Overshoot's transient response, but you will have those kind of errors present in your signal. Okay, next we have the PI controller. This is actually a more common type of controllers, especially used for power supplies. So this uses proportional and integral terms, so that's KP and KI. Use this if you need to remove steady state errors such as offset. You can also use this if your system is quite slow and slow changing. So an application of this would be temperature control for a room. Temperature control is a very slow process. It could take minutes to heat up a room. You don't need to react to fast changes or anything like that, but there will be a steady state that you will want to remove over time. So PI controllers are very good for temperature control. So the pros and the cons of PI. So pros, fixes any steady state errors such as offsets, good for slow disturbances like say if someone opens a door and the temperature reduces down, a lot more accurate than a simple P controller. Now, the cons of this are integral causes a slower response. Simply having the I term, the KI term, makes your system slower. And likely there will be oscillations in the system if you have not correctly tuned it. There's also the problem with integral that if a huge spike comes in and integral doesn't react very nicely to it. But as long as you tune your system correctly, you won't have this issue with oscillations. Okay, next we have the PID controller. This uses proportional and differential parameters. Use this if you need to improve the damping or smooth an outer signal, or you need fast reactions to changes, or if the system does not need to remove any steady state error. If you're not too worried about steady state error, PID's okay. Now, the applications of this, well, actually, there's not really many applications to the PID controller because it's just not commonly used. But you could perhaps use it for a robotic arm where you need fast movement. But if you added an KI component to the robotic arm, it would slow down your robotic arm. So maybe you just wanted it to quickly move and react to fast changes, so PID control's okay. Okay, pros and cons of PID control. So, pros has fast reaction to change and it smoothens out the signal. The main reasons people use differential control. But the cons are it's actually quite tricky to tune and you need to be able to simulate or test for different edge cases because if there's a little bit of high frequency noise, you're going to have a problem. And then of course, very sensitive to high frequency noise. Again, PID controllers are not commonly used. Okay, finally we have PID controllers. As you guessed, the PID controller has all three variables, proportional, integral, and differential. Use this if you need fast response and accuracy, and use this if your system has transient response and steady state issues. So, applications are flight controllers, and to be honest, most things will use PID because they will have both transient response and steady state issues since we live in the real world. So, applications, flight controllers, robotic arms, cars, cruise control, aeroplanes, helicopters, whatever, engine control, process plant control, they will all use PID. Okay, the pros and cons of the PID controller. So the pros are it provides the fast reaction and accuracy. it reduces overshoots, oscillations, and steady state errors, and it provides the most control out of all other variations. Of course, having three parameters PID provides more control over the output as compared to, say, a PI control or a PD controller. And then the cons are it's simply going to be trickier to tune because there are more parameters to be aware of. And it's sensitive to noise due to the KD term, so be careful of KD. And then also the most computationally expensive compared to others. So of course PID having three parameters is going to be more computationally expensive as compared to PI or PD controllers. And to be fair, in the modern day of modern computing, this actually isn't really a big deal because most small microcontrollers can happily do PID control for you. So summary, you don't need all three PID parameters. Use Ki if your system is slower. Use KD if you need faster reaction to change. And use all three PID if you need both properties. To be honest, if you're in doubt, just use PID. And finally, thank you. I'll see you in the next lecture, which is lecture 6, a Python simulation of PID control. Thank you.